point to several other things, but in the recent past, both David and I saw the light, followed it to the promised land here in Davis, California. So, Davis, I want to wish you a happy birthday and congratulations on your career. I know there are many people, students, and colleagues of yours that are here over the years, and wish you many happy and productive years here at Urbana. Yes, UC Davis. I want to close my introduction by making a plea. As most of you know, Carl Woese, one of the greatest scientists, I think, of the 20th century, passed away on December 30th of 2013. Carl himself was trained as a physicist, and Carl transformed biology through the discovery of what we call the third domain of life, which he termed the archaea. For his thinking and for his discovery, Carl took severe criticism from the scientific establishment, especially biologists and people like Ernst Mayr at Harvard, for opposing the view that life was organized into just two domains, right? The prokaryotes and the eukaryotes, those cells with a nucleus and those cells without a nucleus. And Carl used to rage on with Norman Pace that you can't classify something by something it doesn't have. You can only classify something by what it does have. But Carl persisted, and in 1996, he was vindicated by DNA sequencing. Craig Venter at the Institute for Genomic Research sequenced the first rumen methanogen, actually a bug that came out of a cow's stomach. And he firmly established that the archaea was a separate life domain, a third life domain. And the view of all of life on Earth is now commonly referred to as the Woesian tree of life. For his discovery, Carl won the Crawford Prize in 2003. The Crawford Prize is the equivalent of the Nobel Prize in biology. It's given by the King and Queen of Sweden. Carl, I was one of two people that Carl invited from the campus to this amazing event. And Carl used these discoveries as really as an entree for the study of evolution. And just as he overturned the existing dogma on the view of life on Earth, Carl challenged us to think beyond the Darwinian threshold to the forces that shape molecular evolution. So the Darwinian threshold is when our classical view of evolution begins, right? That's when cellular life forms. What is beyond the Darwinian threshold? And Carl believed that there was evolution prior to cellular life, when Darwinian evolution begins, which is part of a broader definition of evolution that even today still has no underlying valid scientific theory. This led Carl to complexity theory and a collaboration with my colleague Nigel Goldenfeld and many of yours, I'm sure, at the University of Illinois during the final years of his life. Nigel and Carl were the core of the biocomplexity theme, which was housed in the Institute for Genomic Biology, where I was privileged to serve as the founding director. And together, they worked on defining the process of evolution. And I underscore the word process, which is very different from what most evolutionary biologists actually do. In 2007, Freeman Dyson wrote the following in the New York Review of Books. Whatever Carl Woese writes, even in a speculative vein, needs to be taken seriously. Dyson termed the Woese hypothesis of a collective network of early life preceding a modern cell, the golden age, and commented that we're now moving forward into another communal stage as a culture, in which he was actually implying an extension of Woese's thinking to the forces that shape society. I know from my many conversations with Carl over the years that he felt that the appearance of life was an emergent property of the evolutionary process, and that the fundamental principles of evolution, beyond natural selection, which he absolutely did attested, along with his contempt for Charles Darwin, as many of you know, that these processes were as yet undiscovered. Carl once said, "We have to try to discover the dynamic of the process of evolution. For this, the biologist needs a lot of help, particularly from mathematicians and physicists who are used to dealing with complex systems. Systems so complex that they iterate by themselves. Life." So my appeal to you today is to take up Carl's vision as part of your mission. As an evolutionary biologist, still practicing, I appeal to you to help us to better understand the evolutionary process. It's the most important problem in biology, and arguably one of the most important problems in all of science. Before Carl died, I promised him that I would bring this message to UC Davis, where there are brilliant physicists, brilliant mathematicians who can pick up his mantle and lead us forward. And there's plenty of intellectual space for you to all join in the fun. So I hope you'll be thinking a little bit about evolution during the next couple of days, in addition to the many fantastic research problems that all of you are working on. And I hope to see you all tonight and to catch up with many of you, some of my friends, and to understand where your field is going as a science. Thanks very much, and have a great couple of days.
Thanks, Eric. And now we'll have a couple of introductory words from Dean Alex Zabrodsky.
Carl and I ran seminars together.
Ladies and gentlemen, colleagues and friends, it's a pleasure to welcome you to the ICAM annual meeting to Davis. As always, we live in a world of evolution and change. We're proud of what we have done. We look forward to what we will do, and there are many unknowns in theory and experiment, and in that combination of theory and experiment known as finance. So we live in interesting times. Let me explain what I do. I wear many different hats. I think you know my research hat in thermodynamics of materials that pervades everything from physics to biology. I think you know perhaps that David Hines and I taught a course on emergence a few years ago, which was a lot of fun. I think you know also that I've been involved with ICAM and with many other organizational things. A year ago, I took on the mantle of interim dean of the Division of Mathematical and Physical Sciences at the College of Letters and Science of the University of California, Davis. That's a mouthful. Interim, I learned, does not actually mean a specific term, although I was appointed for 2 years at this point, so I'm halfway done unless things change. It means that it was an internal search without it was an internal appointment without a formal search. Division, well, we are 3 divisions in the College of Letters and Science: a division Mathematical Physical Sciences, a division which is humanities oriented, a division which is social science oriented, and we're having very serious discussions about how these should evolve. So we come back again to the question of evolution, and I will not say that there are 3 classes within letters and science, analogous to the 3 classes of living organisms, but still the those. And what happens next, we do not yet know. Let me reminisce one moment. At first, maybe not the first time I met David Hines, because the first time we had a long talk about ICAM. There was an ICAM workshop in Lawrence Berkeley Lab, and at the end of it, it was still daylight. It was summertime roughly. So we had a nice restaurant to go to in Berkeley, and we decided we would walk there. So we walked down the hill from the lab and across town, and that gave us a lot of time to talk about things, and I think really cemented our understanding and our friendship, and we have interacted ever since. I have enjoyed ICAM. Let me say something more about Davis. Davis is growing. the plan, the so-called 2020 plan for the university is to grow by about 5,000 students in the next 4 or 5 years, something like that. By a 20-to-1 student-faculty ratio, that would mean growing by about 250 faculty. But the demographics here are such that just to stay at the same size, we need to hire. And basically, the best statistics suggest that the total number of faculty that we need to hire in the next 5 years is something on the order of 600 to 800. It's staggering. It's something like 35 to 40% of our total faculty will be new 5 years from now or 8 years from now. And all of this, again, on the backdrop of science, politics, service to the state, and of course funding. It's an exciting time. You'll be hearing more from us. So again, welcome to Davis. I look forward to the conference. I wear my many hats, including this one. And I look forward to interacting with all of you, and I'm sure that we will have a wonderful time scientifically and personally. Thank you.
So I just wanted to say a few words about ICAM. So yes, in 2 weeks, I think it is, David, we turn 90. And we are 15 years old. The birthday was in December of last year. And as you know, we are interested in emergence, and emergent phenomena are those that owe their existence to interactions between many subunits, but their existence can't be deduced from a detailed knowledge of those subunits, like how can a collection of molecules think about what molecules are. And they include examples such as novel superconductivity, antifreeze proteins and how they function at work, like the one I showed there, and defect structures in liquid crystals, like the little movie from Even Smolniak's group down below. ICAM was founded in 1998, as we just said. It became a multi-campus research program with 9 founding branches in 2002. The lead branch was Los Alamos from 2002 to 2006, and it's been at Davis since 2006. We now have 69 branches worldwide, representing nearly 90 universities, and for the past 10 years we've had a little bit of support from the U.S. National Science Foundation through the International Materials Institute program, which NSF, due to sequestration and budget cuts, has decided to close that program down. I'll say a little bit more about that. We'll be talking about that issue throughout the meeting, but this is just to show you something about the growth of ICAM branches worldwide. And I should mention every branch, when they join ICAM, commits to actually contribute to the ICAM program through in-kind or direct contributions to our branch funds. And we also exchange junior scientists around the world to build our network. This is a map of those exchanges over time. We have found that those exchanges lead to some terrific science. One of our fellows, Lodan Sinyak, who's going to give a presentation here at the meeting, had a Nature article, actually the last couple of years, 2 different Nature articles on their work with colloids and liquid crystals. And we also have schools for young scientists, sponsor schools for young scientists and workshops. We have the ICAM school is actually going on in South Africa this year, and we have had the ICAM school rotate around the world from China to Australia to Argentina to Boulder to England and now to South Africa. We've had substantial impact for a 15-year-old. We've had over 290 ICAM-related publications in 15 years, which have been cited over 7,000 times. Many of them in high-impact journals, including A Color of Science. We've archived a number of our lectures. We plan to archive, with permission, the lectures from today's meeting. If you don't want it recorded, that's okay. Just let us know. Those archived lectures on SciDeep.tv have collected over 600,000 views since we started putting them there. We've had a number of our young scientists go to university positions at great universities and also in industry. And we've also, thanks particularly to David and to Piers Coleman, been heavily involved in science engagement and education We created the online science museum at emergentuniverse.org, and David has a product of, I think it's, not 88, I should say 2008, a product of David Klein's 2008 is the Global Science Engagement and Education Network. And we also have annual Science Engagement and Education Awards. This is just showing you the growth of ICAM participation from 2007 to 2012. The total growth in participants, you can see, is quite dramatic, and that also reflects a growth in all the areas of senior faculty, graduate students, postdocs, undergraduates, and we are physics-centric, as Harris alluded to. About 70% of our participants come from physics, but the other 30% do come from a number of other disciplines. So we're physics-centric, but we're definitely a multidisciplinary organization. At Davis, ICAM since 2010 has supported workshops organized by 9 UC faculty. We've provided 4 exchange awards to or from Davis since 2010, 13 junior scientist travel awards since that time, and about 27 trips by senior scientists to ICAM meetings. And 3 of the early ICAM postdoctoral fellows, part of our fellows program, went to UC Davis chemistry faculty, Susan Kozlerich and Yang Liu. Coming up later this week, ICAM is providing support to Alex's meeting on carbides, nitrides, and related materials in Earth and Material Science, which is a fascinating interdisciplinary meeting between material science, planetary science, and earth science. We're sending students to the Gordon Research Conference on Biomaterials and Interfaces that's organized by Professor Atul Parikh of Material Science next month. And we have decided to award an ICAM postdoctoral fellowship to Steve Wachikowski and David Ben-Simone beginning in July. And where are we going to go? Well, we have a great meeting ahead of us. We've just received preliminary word that the U.S. National Science Foundation will support bridge funding for ICAM to go for a PIRE Award, a program on international research and education. Those proposals are due this summer, with awards to begin next summer, if we're successful. And we received some support from the Gordon and Betty Moore Foundation for workshops on quantum matter. And to discuss the future of ICAM, please make sure you come to the town hall meeting tomorrow from 8 to 9:30. I think that's all I have to say about ICAM for right now. It's just an introduction to ICAM. My co-director, Peters, is right there. And Maura Green, the chair of the Board of Governors, is there. So the lead officers from ICAM are all present right now. And with that, I'd like to begin the scientific part of the meeting.